Welcome to week 3, I think.
Or week 3 vlog.
Yeah, week 3 vlog of Mind the Traps and everything else.
So I'm going to start it off. So some of you are probably wondering what I do. We are the brother duel, and Chris has been the one who's been mostly working on the technical development stuff, and I've been working mostly on the business and marketing stuff. So I've been handling all social media. And recently, even though it's a little early, I've been starting to look into promotional campaigns, so like Kickstarter, Indie Mega Booth at PAX, and just other events that could help build our publicity for this game. And been doing a lot of research, a lot of interesting stuff, like just getting to know how Kickstarter works, how to even get into the Indie Mega Booth. It's a very extensive process where the judges look at your game, but also look at your company, the individuals operating this company. Do we contribute to the community? And so that's the reason for our blog, to really showcase that we have been, blah, blah, blah. So, so currently I'm running a blog, but I want to share some of the preliminary plans so far. So, so what I've learned so far is that a good time to sell indie games is the months that are not the hotbeds for the AAA studios. So AAA companies love to sell their games around the September-December timeframe. And so we're going to avoid that. So if we target, let's say, a launch date of end of August, that also allows us a lot of what do you call those? Promotions, like seasonal promotions during Thanksgiving, Christmas. And so assuming we launch at the end of August, that gives us the opportunity to attend PAX near the beginning of August, middle of August, get some PR there, work with the press, and then before that, we're thinking about doing Kickstarter over in the summertime. So the funding will help us, continue to work on this game, add a lot more features that we've been wanting to add, and yeah. So that's the plan so far, but we'll see. It's very early, obviously. We're still very early in development. We have an artist coming on board next year, February, March timeframe, and so it's going to get a lot prettier, hand-painted textures, and even that, when that comes in, I see the art as being a really huge marketing point for our game, so that could change a lot of the plans we have.
Yeah, shout out to him, Conrad Fay. He did the knight that you guys saw in the prototype, and he did some nice painted textures, as you'll see in the statues. But we couldn't really implement them for our characters because we needed a much more, obviously colored players, red, blue, etc. So, and then we were kind of strapped on time for that week, and he had, I think, 3 midterms, so he couldn't do much. But he'll be joining us again next year, and hopefully making us some nice painted textures for everything.
Yeah.
Okay. My turn. Okay, so for today, I am going to talk about what we did so far this past couple days, this past week. Let's see, so far, did we talk about camera working last week?
No.
No? Okay, alright, let's do that. Oh, let's get, stop it. No, I didn't want to open Git. Okay. So, camera. Could have sworn I did talk about it last week, but I'll talk about it again anyway, because why the hell not? Okay. So how the camera works from the prototype was relatively simple, because everybody was on the shared screen. It was just a camera that was centered on the center point of each player. But because we were short on time, we couldn't really fix the little small bugs, like, for example, if the players were too stretched out, you could have problems where the camera, because it doesn't adjust its view, it just adjusts its position. We would have issues where players would be off screen and nobody would know where the hell they are and what the hell they're doing. So we had to do a couple fixes for that. Some stuff we had planned, for example, would be if they move off screen, they automatically teleport back. kind of like a lot of games do, like for example, Super Mario Bros. For the Wii. I forget which one's that one, the multiplayer one, where people would, if you're off screen, you'd pop into a bubble, and then you'd float around, and it was everybody else's job to save you so you could continue. We had a lot of worries about, like, for example, if you were too far away and people decided to troll, like they refused to progress, so they would keep running backwards. Then we would have we decided the nice system of just instantly teleporting the people who are way behind to the group would be a better solution. Let me just show you how that works. But here we have the client and the master. So another thing was how do we determine between the difference of when the players want to go back together versus wanting to go forward. So what we have right now is, you'll notice, like, if Orange decides to go back, he gets instantly teleported. He wants to go back, camera doesn't let him, or camera lets him to a certain point, and after that camera locks in place and says, no, you're not allowed to. But we have a nice little option where if Blue decides to go back with him, they can both go back. So if one person decides to troll and does not want to progress, all the other players have to do is just keep moving forward, and soon enough, there you go. Everybody's nice and grouped again. But if the group decided, hey, I want to go check out that like weird island over there, it's interesting, how about we go that way? Then all you gotta do is have everybody group up, and the camera goes back with you. So I'll do a quick alright, I was messing with some rooms earlier. Ignore this bug. Oh. Actually, that's a new bug. I'll fix it. Anyway. Yeah, game dev, lots and lots of bugs. Fix one bug, 5 more come up. I'm gonna jot that down. Okay. Anyway, let me show you how that's done. How the camera is done. So, first off, we have 2 different things. This camera is worked with 2 different parts. Our first part is an object called camera controller. And all he is a blank object with a camera attached. And outside of that, we have a nice giant box collider. This box collider is essentially what determines when the players move out of the view. And it's nice and big, and we can adjust it later for different camera sizes. Right now I just set it to an arbitrary camera size that was about the size of my viewport. But yeah, we can change that to be dynamic later as we start to figure out you know, resolutions and all that stuff. Easy fixes. Anyway, it's not very pretty. But here, this is the kill, essentially. If player touches or ends overlap of the box, it makes sure, first off, we make sure that it's the server doing this so we don't have any problems. And then we check to see if he is, we got to figure out where exactly he's going to go to. So right now what happens is, what we have is a get all actors of class, and we find all the other players, and we make sure, we check to see which player isn't falling. And what happens is the falling player will then teleport to the other player that isn't falling. So all this is just this checking through. It's a bit crude right now, and it doesn't do as much checks as it needs to. But for now, for testing purposes, as we continue on, this will do. Like other checks we have to do is make sure like it doesn't pick another falling character. Right now it just picks a character that isn't itself and teleports to it. But if we have, say, 3 players and 2 players are falling, there is a chance of player 3 teleporting to player 2 who is also falling, player 2 teleporting to player 3 who is also falling, and they keep going until the random number generator decides it's at player 1. There's no random number. Anyway. Okay, on to how the camera moves. So right now what we have is, with our system, of, let's do one player. So with our current world generation system, we have every single section, I guess, like paths and rooms. We'll call them sections for now. Each section has a designated exit point. So we have a general idea of where the players should be headed, like a general forward direction. In this case, the exit is here, therefore the players should be headed towards that way. And we utilize this information for our camera to make sure that the players are always heading forward, ideally, unless they want to head back as a group. Okay, and how that's done is in the level blueprint, when the world is first generated for the first time, the first path, which is the nice little white one here, which will be changed later, is set as the next exit here. That next exit, oh no, sorry, over here, is set as the first path. That first path is then plugged into a function. Is it a function? It's an event. An event in the cam controller. So this is then where it calculates where it should be. So it basically just grabs the value of where the exit is, whether it's a room or a path, and then calculates where that exit should be, and this next exit value gets calculated as you go along. Next we have a little, where is it? The entrance phone. This is placed in every single room, and what happens is whenever a player enters this, it finds the camera controller and tells it that, okay, next exit is now this room. So basically, if you can follow the logic, how it works is basically we have an entrance here in a invisible entrance volume. Whenever a player enters it, it tells the camera that, okay, next exit is over here. Player now enters this one, next exit is over here. And it keeps going, so the camera has a nice little forward direction of following the pathway. There you go. If you guys want a more detailed description, I can do a nice little tutorial for you. Just let me know, shoot me a message. In the meantime, here you go. There's that, and here's this. Okay. Let's see, next we will talk about enemy AI. Okay, so this week was I think the second time I touched the behavior tree in Unreal, and as you guys might have seen from the regular blog post the other day, that I quite like Unreal's AI system. The behavior tree system is really nice. As you can see, it's very simple to follow. Basically, all it is just a nice visual way of keeping track of your code, so that you know the general direction. So you can better have an idea of the general what your AI should do. So what I did was I followed a tutorial. That's Blender. God damn it! I didn't want to open that. Well, you can find it on the blog post. Anyway, the tutorial is by Unreal. Very nice and easy to follow, and it works amazingly. All it does for the character, excuse me, is Unreal. Why? This computer hates me, I swear. All this AI does is basically it shoots a raycast, it finds players, and then it follows them. Once it doesn't see them anymore, it returns home. I have an example right here. Let's make these raycasts visible so you guys can see it. For duration and for duration. Okay. So here we have our enemy. He has detected our player, But what we did was we set a little nice a range so that if our player is outside that range, he considers it, oh, I can't see him anymore. Once he doesn't see me, or if I'm behind a wall, he waits a bit and he should be going home. Unfortunately, he sees me though. There you go. And now he's trying to go home. So, very simple. One problem I did come across was that he would not go home, and for the life of me, I could not figure it out. His AI tree was following everything perfectly and then cutting it here, where it should be going move to home location, which is set in the, if you guys follow the tutorial that I linked in the blog, it should be just setting that location where you placed it. So in this case, it would be right here. And then he should be going home after. But for some reason, he would just stay there, or he would keep chasing me to the ends of the earth. And what I learned, how I fixed it, and what I learned is that move to works only if the location you input is valid. So what happened was my little AI was something like a little bit too high, just like this much, and he would not move back. This little cheeky asshole would not follow my instructions. So keep watch out for that, guys. Let's see. Okay. Oh, another thing we did this week was we slightly reworked the procedural generation a little. This is gonna be a quick. So if you guys followed it from the last video, I talked about procedural generation, and you can see from another blog post even earlier how I did it in more detail. But we did a slight rework. How it currently works is that how it previously worked was that it would spawn the actor of the room, and in the actor's construction script, it would set all the important information needed, like coordinates of where the entrance and the exit were. And with that, we would calculate where it would be and then move it. But the problem was that in order to move these things, everything needs to be dynamic. And as a lot of people know, and as I've learned recently, is that dynamic is not very great for performance. Static, on the other hand, is much more preferred, especially if your stuff isn't going to be moving very much. And in our case, these levels shouldn't be moving other than, I don't know, for generation. So we had to rework that. Also fixed a lot of other stuff along the way. So how we reworked that was we had a nice little, rather than having, so the problem I came across was that Unreal, as of right now, does not allow you to edit the parent variables. So everything is a child class of a parent class. And that parent class has the important variables we need. And the reason why we do this is because this way, for our level blueprint, all we have to do is cast to a single kind, in this case the parent variable, grab the information, and then start moving things to the right place, or start calculating where things should be. But the problem about Unreal's current setup, which I'm told they're actually planning on fixing, is that I can't edit these variables in the details for the child. They just don't show up. They're not here, they're not anywhere. I can edit it during runtime, or I found that editing it in the construction script is better, because construction scripts run right after the actor is spawned and before any all other code is done. So right after it's spawned, these values are changed, and I have the values I need. So the problem I came up with was I encountered was that I couldn't spawn a static object, have it run its construction script, and then move it. I had to spawn something else instead, get that information, and then move it. I don't know if anybody's catching up on that. I'm kind of confused myself on what I just said. But basically, I had to fix it by having it spawn a different object that had the information and attaching the room to it. So, in a much simpler way, basically what I did was I had a child class that would be just a blank object. It would just be an object with coordinates that didn't matter. They were arbitrary. And in it, it would have the construction script that would have the information it needed, as well as the room it's attached to. So in this case, we have room variables child1 variables, and it would be attached to the room variables child1, as you can see here. And what we did in the level blueprint was now, instead of spawning each individually, let's go to spawn room. Instead of spawning the room and then moving it, we would spawn the variable, which didn't matter if it was static or dynamic because there was nothing attached to it, get the variables we needed from there, calculate the entrance location and exit location like we needed to, and then spawn the actor of the room itself where it should be the first time. So now everything can be static, now everything can be nice, spick and span, and we're all good to go. Yeah. Okay. I think that's it for what we did this week. Oh wait, no, sorry. We did a bit of testing for the online stuff. Where is it? There we go. It made a nice little blog post just to see what was causing all our lag issues. For the most part, this computer was working fine and beautiful, 62 FPS at all times. But then again, this computer is kind of high-end, and we can't really assume that everybody else has high-end computers. My computer in the back over there was having problems running certain stuff. Namely, for the most part, what we found is that point lights, as we also researched online, point lights seem to cause some performance drops. That computer would drop something like 3 to 5 FPS just for having a point light in view when there was a lot of other stuff going on. And we tested that by just, having two players, having one player move out of the screen. Usually what we did was we had them step on the spring traps, the cylinders here. They would launch them all the way up and out of the screen, and we would notice a actual FPS increase for player 1 or player 2 being out of the screen. Another thing we noticed that we were planning on changing eventually, but just not currently, was that these walls are really, really, really high poly, and they would cause some performance drops as well. So if I can pull up a wall, let's see, it's 4,000 vertices, 3,000 triangles, just for a simple wall. And in a normal scene, this would be something like, by my estimate, about 15 wall sections. Yeah. And that would cause a performance drop of about 5 FPS just for being in view. Whenever they weren't in view, though, we had no problems. But that's because of, rendering. Anyway, occlusion culling. So yeah, we do plan on replacing these walls eventually with nice flat cubes that are normal mapped instead. So they still have this nice, or painted. So they still have a nice decal to them to make them not just bland, square, one-color walls. Yeah, I think that's it for what we did this week. Upcoming week, we're gonna finish up some rooms. As you can see, I have the makings of a room right here. Yeah, this is gonna be the exploding enemy. It's gonna be a nice little dramatic entrance as this thing lowers and the enemy comes out and chases you. That'll be all fun. And we should have the grounds for some nice testing of some tweaks for mechanics and start cranking out rooms, and we should see some nice good progress for the upcoming month. And yeah, I think my brother has something to say.
That was pretty much it.
Oh, that was it?
Yeah.
Oh, okay. I stole your job?
Yes.
Okay, alright, well.
Orders.
Alright, yeah. So I think we'll call it cuts. We'll cut it here today. And next week, let's see if we can do some mini game room building, some actual coding for that section. I'll see if I can do a dueling room for you guys, or maybe some of the new mini games we come up with as we go along. And yeah,